Now we are going to see the examples that we have studied in this week, and we will consider those examples and see them how you can solve them using Python. Okay. So the first example, so I have saved it over here. Let me just copy it from this side. So, sorry. So this is the example that we had, that during a competitive exam, a reasoning test is administered in a 2-day period, Monday and Tuesday. And each of these days, 10,000 individuals participated. For Monday and Tuesday, both we know that they both followed normal distribution with different means and standard deviations that is given to us. And we had to randomly choose 25 individuals from those who gave the exam on Monday, and you select, let me just bring it down, and we select 20 individuals from the group who took the Tuesday exam and denote their score as this. So what is the distribution of this difference of the sample means? So if you have to write the code for this and solve this problem, then let us see how we can do that. So first of all, as you know, we have imported your NumPy, and matplotlib is also there. And from scipy.stats, let us see if you have imported your norm function. No, norm we have not imported. So let me just write from scipy.stats import nor. Okay, so this is used for working with the normal distribution. Now we need to specify the parameters for Monday and Tuesday. So the mean, first of all, let us just write mean underscore m. This would mean it is for Monday. Mean is given as 68 in this case, and standard deviation for Monday is also given to us, which is 8 in this case. And what is the sample size that we have taken? Maybe write sample size, sample underscore size underscore m. This is basically given to us as 25. This is for Monday. Likewise, we can define these for your second day, that is Tuesday. For Tuesday, the mean is 52. And standard deviation given to you is 9. And finally, the sample size is 20. Right? Now, these are the parameters that have been defined. Now you need to calculate the sample means for both of them so that you can see and calculate the mean difference, that is xm bar and xt bar, right? x1 bar minus x2 bar. x2 bar is what in which you are interested in. So we will calculate the distribution of this. So let us write mean underscore difference is mean underscore m minus mean underscore Tuesday. Okay, and STD of this difference, standard deviation, would be, because the formula is sigma 1 square over n1 plus sigma 2 square over n2. So mu1, this is mu1 minus mu2 basically. So maybe I could write here, comment it. So mu1 minus mu2. And for the variance, it is sigma 1 square over n1 plus sigma 2 square over n2. So in this case, since we are writing the standard deviation, we also need the square root. So we can use this NumPy here. NumPy's library is this one, square root function. So np.sqrt. So here we need the standard deviation of Monday, that is sigma 1 square, STD of Monday. We need the square of this. We need it power 2 divided by sample size of Monday, that is sample underscore size underscore Monday. Okay, so here one more bracket would be there because first this will be solved, then plus of the same quantity over here for Tuesday, sigma 2 square over n2. So here we would have, instead of m, you will have Tuesday, and sample size will also be for Tuesday. Okay, Now you can print using this f string over here, that x underscore m minus x underscore t, these two, it follows your normal distribution with mean and variance. So this is the mean with which it follows, so it would evaluate it. So it is better to write in curly bracket, so mean difference, and then you would write the standard deviation differences. Okay, and since in the normal distribution we usually write variance, so we use this for power, so square. After this we will close this. Okay, so first it will evaluate mean difference and this from the above two lines, and then it would print the corresponding statement that the distribution of the difference of the mean follows normal distribution, and so on. So let us see. Name std, sorry, this one would be t, sorry, yeah, this is the mistake. Yeah, let me rerun this now. So what it is displaying, it is showing that the difference of the two means follows normal distribution. So mean is coming out as mu1 minus mu2 is 16, and this variance is basically sigma 1 square over n1 plus sigma 2 square over n2 is this, right? And in this case we had the second part where we had to find out the probability that this difference is greater than or equal to 10. So for that to hold true, we have to find the z-score. So if we just write here only, so z-score basically would be, so 10, we want it to be greater than 10, so 10 minus the mean difference, this thing, x minus mu by sigma, and we divide by this standard error over here. Okay, we can print this z-score, whatever is the value, we can see what it is. Print z-score is equal to, so z-score, now we are specifying this formatting that we want it for 4 degrees of freedom. So this would be evaluated and it will print the corresponding z-score from this line. Now it will calculate the probability that 1 minus of this, because here let me just write it, 1 minus norm.cdf z-score. Z-score is what you have defined just now. So here it is calculating the z-score, and norm.cdf is basically used to calculate the cumulative probability of observing a value less than the z-score, right? But here we are interested in, if the difference of these two means is greater than or equal to 10, it means that we need to subtract it from 1. Okay, so that is why we are subtracting it over here. So once the z-score is calculated, you will use this function over here and calculate the cumulative probability, and then you will subtract from 1. And finally, you can print this if you want. Let us see. Print. So probability that xm minus xt, xm, in fact it should be xm bar. Okay, so here we have not displayed that. We are just writing xm. Okay, x, it should be the mean difference of the two means. This is greater than or equal to 10. So this it would print, it will first solve this probability and it will specify up to 4 decimal places. Okay, so here also z-scores, this is a format specifier, up till 4 decimal places, and this would end it. Okay, So the difference of the two means is following normal with this mean and variance. And here also we are writing the z-score came out to be minus 2.337, and you can cross check it, the one that we discussed in the class. And here you can see that when you find this probability, it comes out as 0.9902. So you can easily solve these examples using Python. So in earlier classes, we have seen that given from that OTT data set, how do you solve that, right? You have to extract the column and then you can apply it. And now here directly, if suppose somebody is giving you this concise information, then you can write these codes to find out the desired answer. Okay, so this is your first example. So let me just write over here. Next, we can have your second example. So let us just copy it from here. Our second example was that you have two separate experiments and the battery life of two different brands of smartphones is compared. In the first experiment, 20 smartphones from brand A undergo testing and their duration is recorded. They follow normal. Again, from this second one, 25 are given. They both are normally distributed, and you know the mean, and here you can see that variance mean for both of them is given, and additionally their standard deviation is same, that is true, right? So this is the second case that we studied, and in this case you will not have sigma 1 square and sigma 2 square, rather you will have just the same sigma. Okay, so in the same way it can be written. You have already imported numpy, so let me just write import scipy dot stats as stats. Okay, you can specify the parameters from brand A and brand B. So for that you can write mean underscore A is equal to, so here it is given as 17, and it's sigma. We can just write sigma because in both the cases sigma will be same, so maybe we can just repeat it. Sigma A is given to us as 2, and NA, that is the sample size, is given to us. In this case it is 20, and in the other one it is 25. Sigma B and NB. So this is 2, this is 25, and mean for B is 15 hours. Okay. Now again you have to calculate mu A minus mu B, that is mean, the difference of the two means, and the corresponding standard deviation. Maybe we can use it from here, this formula that we have already written. We can edit it. So the mean difference would be mean A minus mean B. Okay, and the standard deviation, this would be NP dot square root of this, or maybe if you just want the variance, you can directly find variance, and here you do not have to calculate this square root. Okay, so just you will use standard. So here we have written sigma, so let me just use sigma. So sigma underscore A would come, and here n underscore A would come. Okay, and this side it would again be sigma underscore B, and here it would be the sample size corresponding to B. Okay, so mean difference and variance you have obtained. Now you can calculate the z-scores. So z-score would be, because you have to ultimately find the probability that the difference between their means is greater than equal to 0. So basically for A, x bar A is greater than equal to x bar B. For that you need to first of all find the z-score. So z-score here it will be 0 minus, because 0 is the value with which we want to see. Here this mean difference would be there, and you would divide it by there you have standard error, right? So here maybe either you apply the square root over here, right, when you're writing the variance instead of that, as we have done earlier, or you can just simply use the square root function at this point. Okay. So you can now calculate the probability of 1 minus stats dot nor dot CDF, and here you can write the z-score. Okay, so it will calculate this probability and then it would subtract from 1, because it would create it, because here we want it to be greater than or equal to 0, right? So here it would first evaluate your cumulative probability of observing a value less than or equal to the z-score, and when you subtract from 1, it means that you are interested in the random variable, that is, it is greater than or equal to this. Okay, so if you run this, so okay, so somewhere this bracket, okay, yeah, NB is not defined. Now you want to print, because here we want to print, so we have not given that command. Print f probability that xa minus xb is greater than equal to 0. This is same as this probability, so this is prob, and we want it to 4 degrees of freedom, so we can specify that. You can see that it comes out as 0.9992. So here one thing that you notice, that instead of writing the square root in this case, you can use the square root at this end. Now another thing is that we have written 1 minus stats.norm.cdf. So we have till now been using norm.cdf directly. The reason is that here we have imported scipy.stats as stats itself. And when now in this case you need to mention, because this is the stats that you have, this is the alias or the convention that we have used. Okay, we will be calling this with this stats. So stats.norm you have to write. So you are using a function from this scipy.stats. Okay, otherwise if you have imported, as we have mentioned here, from scipy.stats, if you have imported norm, then you can directly write norm over here, as we have done. Okay, so you have imported the norm object from the scipy.stats library. So this is the difference. Both are same and correct. So it depends on how you have imported it, and that same function you would use here, right? If you have imported this and you have not imported the norm, then just directly writing this like norm.pdf, if you write, then it would be wrong. In this case it would give you, because we have already imported norm somewhere else. So here we need to mention this in this way. So the third example was on your, let me just show that. Here we had to calculate your pooled standard deviation. So in this case, what we have to do, I can briefly tell you that first of all, these are the data values that you have to enter. So for this, you have the NumPy library, and these you will define these as arrays. Okay, and you will specify their means. You can find the means basically using the NumPy's mean function for both of them. And so maybe I will just write for this. The next one you can solve it on your own. So the third example. Okay, so let us import NumPy as NP. Now we have to define the data for your plant A and plant B. So let me just write data underscore A. So here we will use NumPy's array, np.array we are defining. And what are the values? So these values we have to enter, right? So 1.59, 2.51, 1.85, 1.57, 1.10, 2.08, 1.15, 4.45, 6.63, 0.97. So this is for the plant A. Likewise, you can define for plant B also. Data underscore B is numpy dot array. Okay, so here if the values vary while copying down from above, so you don't have to worry about that. Be it any value, you will get some or the other answer. So this is just an example to show, nothing else. 2.28, 1.27, 4.89, 7.29 and 1.06. So you have now created these arrays. Now we can calculate their corresponding means, right? Because for finding out this pooled standard deviation, you need the means and their corresponding variances, or you can say the sample standard S1 square and S2 square. So for calculating the mean, so let me just write x1 is found using np.mean of this data underscore a, okay, and x2 would be basically again the same thing, np.mean function data underscore b. We can likewise find your sample variance. So here np, we will use this std function from your numpy, so it would be for data underscore a, and here we will also need your degrees of freedom. Basically we need to specify this one so that it calculates your sample variance and not your population variance. So I have explained this delta degrees of freedom last class. So DDO, here also it will be 1. If it is 0, it will consider it as your population variance. Now you need to specify what is the sample size. So here both of them are of the same size. Here we can see the length of the data. Suppose it is a large array. So you can find this way, data underscore a, you can use this length function over here. N2 would be basically length of data underscore b. Okay. Degree of freedom would be n1 minus 1. We know that it would be n1 minus 1. And degree of freedom for the second one would be n2 minus 1. The degree of freedoms and everything has been specified. Now you can calculate the pooled standard deviation. Pooled standard deviation, what is the formula? You have if you are finding the standard error, then it will be square root. Otherwise, SP square is basically, you have the degree of freedom, right? N1 minus 1 into S1 square plus N2 minus 1 S2 square divided by N1 plus N2 minus 2. So we are finding this. So let me just write SP NP dot SQRT, and here we would specify, so degree of freedom, the first one, that is N1 minus 1 into your first N1 minus 1 into S1 square. So here you will have square, okay, and you will add up, what is the other term? df2 n2 minus 1 into s2 square, s2 and again power 2 s2 square, this whole thing divided by df1, that is n1 minus 1 plus n2 minus 1. Okay, and you can print, we can just see what is SP now. Okay, so something is missing. N1, oh yeah, here I should have written this. So it is going up to 1.891 something, so many decimal places. So if you want to format it up to 4 or 2 decimal places, you can use this formatting and print your result. So likewise you can do for other examples, because here in this case again you will enter this data, okay, and you have to find your t statistic in this case. So you will calculate the sample mean, the before diet, because here in this case you will have DIs, the difference of the two, before diet and after diet. Mean differences corresponding standard deviation. So DI would be calculated, then sample mean, that is D bar, SD would be calculated, okay, and your length you can calculate and find, just substitute in the formula and you will get the answer to that. Likewise for the proportion also, you can define the proportion, what are the different proportions, the sample size in this case, and you just substitute in the formula of the standard error. So standard error would be basically P1 into 1 minus P1 divided by N1 plus P2 into 1 minus P2 over N2. So in this case, for these values, you can just write the code for this. Maybe you can try at home on your own and see what will be the code to these. You can calculate the z-score then in this case, because it is saying that you want to see what is the probability that the proportion of medicine with this side effect from drug manufacturer B exceeds that from drug manufacturer A. So you need to calculate the z-score. So 0 minus P difference, okay, the difference of the two means, divided by the corresponding standard error. And finally you can calculate the P norm. Okay. So basically for any given problem, you can write the code as I have just explained the process of doing that. These are basic steps that you need to follow. Thank you.